So I've been looking through the instruction reference for CX-Programmer and I found some interesting functions. So I'm going to make a new version of the night rider lights that I made in the previous video, and this time I'm going to use function blocks, because with function blocks it will be easier to create more outputs in case you have a bigger PLC, and it will be much cleaner in the main program. So the first function block I'm going to make will be a normal ladder, and we're going to name this flip-flop, and we're going to need some variables. And the first variable I'm going to name is Tim1, and this will be a timer variable for the first timer. We'll have a Tim2, also a timer. I will have a speed input. That will be the speed for the analog adjuster, and this is going to be a D word. I tried it with a word before and it gave an error, and if I use a D word, which will be double the size, then there's no error. So I'm going to use a D word in this case. I will also have a temp value, which will be a D word, and I'm going to have a converted, and that will be a normal word, and the converted will be the value that I'm going to use for the timers. This is wrong. This needs to be an input. And I'm going to have outputs. I'm going to have two outputs, and I will show you later why. So we'll have an output 1. That will be a bool, and an output 2. Okay, we're going to start the main program in the function block. We'll start with an always on, and the first thing I'm going to do is to divide the analog value. The analog value goes from 0 to 255, and I'm using a 10 millisecond timer. So if I have a maximum value of 255, there will be 2.5 seconds in my delay, and that's too much. So the first thing I'm going to do is divide this by 5. And to do this, we're going to use the forward slash, that's a divider. We're going to divide the speed into 5, and the output will be in the temp value. Again, we're using an always on, and now we're going to use the BCD like we did in the previous video. We're going to convert temp into converted. But if I turn the potentiometer of the analog adjuster all the way to 0, then my timer will not work properly. So I want to make sure that there's no 0 value, and to do this we're going to insert here a larger than, and I want to have a larger than value for my temp. It needs to be larger than 0. So this means that it will only convert the value if the value is larger than 0. So my start value of my timer will always be 1 or larger. Now we can start making the timer function again. So in this case we will have Tim2. It's a timer H. The timer's name is timer1, and the value I'm going to use is the converted value. or 1. So this is my timer function, and I'm going to need timer 1 to output 1 and not timer 1 to output 2. So this is my function block, and if I go to the main program, I can use a function block, and I can select, I only have one at this moment, so flip-flop number 1, and we can see that we have an enable and an enable output. This is to enable or disable the complete function block. We have the speed input and we have 2 outputs. In this case I'm going to use my switch that's located at my first input for my enable, and then we need this one to name all the inputs, and the speed is located at address 642. We know from the previous video the output will be into W0 and W1. Now what happens if we do a simulation? I'm going to run a simulation, and because this is an actual value, I'm going to need an address. And let's fill in 50. Value is 50. And remember that inside the function block, the value is going to be divided by 5. So if I set this one on, it will be 10 milliseconds. So if we change this value to 200, the function block is working. The next function block I'm going to make will be structured text. And I'm going to name this output select. And the structured text is basically a normal programming language. And we will have an input. Input is going to be a word, and the input will name a value. And we have 5 outputs. Output 1. Outputs will be bools. Output 2. And output 5. So we can start typing. And if we start typing, we get some suggestion words. So if a value, and since I made value a variable, it will also show up in the list. So if a value equals 1, then output 1 needs to be true. But I need to have a colon equal in this case, because the equal sign here means that it compares value to 1, and the colon equal means that it will actually make the output true in this case. And we end our line with a semicolon. we're going to use else. So if the value is not 1, then my output 1 needs to be false. And we end with an end if, and we copy this 5 times. We'll have a number 2, a number 3, or 4, and a number 5. Output 2, output 3, output 4, and output 5. Go back to the main program, insert my function block, and we'll name this out cell 1. And out cell 1 will have a normal on flag for the enable. So it doesn't matter if it's always on or off. So. And for the value, we're going to use H0, and my outputs will be 100.0, 1, 2, 4, and 5. So let's run our simulation again. And this time I don't care about my timer, I only want to check my structured text function block. So we're going to go back into the memory, and we'll have H0. H0 is 0, so none of my outputs will be on. If I make it 4, output 4 is on. If I make it 1, output 1 is on. So these are the 2 function blocks I'm going to use in the program. So now that we have a function block that uses a value to select an output, we will need to figure out to increase or decrease this value. And to do this, we're going to need the pulse from the flip-flop timer. So W0, if my W0 is on, we're going to use an add, and the add sign means that it will only execute this command once. And H0, add 1 to H0, and we'll put it back into H0. The same for subtraction. So this is obviously not going to work. So we need to have give it a reason why it should add or subtract. And to do this, I'm going to need the output 1. And I'm going to need 100.5. So if my output 5 is on, and we're going to make keep, and we're going to keep value W2. Keep is basically a set and a reset combined into one. So if my output 5 is on, then it will set W2, and if my output 0 is on, it will reset value to. And the reason I'm using the other output for my timer is because it needs to keep the added value until the pulse goes down again. I will show you in the example when it's finished. So we'll have a W2 and we're going to insert W2 here as a NOT and a W2 here. And I'm now going to run the program again in the simulation. Set this one to 1. It will count to 5, and it reaches 0, it will reset and it will start counting up again, and now it will start counting down again. And if you look at my W, you can see that it will only react when the pulse is going to the other state. Otherwise it will skip step 5 because it will immediately subtract 1 and 5 will not remain on. So this is the basic program, but I'm going to add one more thing, because if I set my switch to off, the value in H0 will remain to the number it's already in. So I'm going to add one more step, and that is a move. And that means that when I set my switch back to off, I'm going to move 0 into H0. And what it does here is when the switch is off, it will automatically reset my H0 value back to 0. So the next time I start up my timer again, it will start with 0, so it will always start at my first output. And it doesn't start in the middle. So that's it. We can upload it to the PLC.
So when I flip my switch, it will go from 1 to 5 and from 5 back to 1. And if I turn my switch off, it will always start from position 1 again. And because we set the divider in the timer function, I cannot go lower than 1, so it won't go berserk. And if I set it all the way to the max, it won't take forever.
So as you can see, the program is a bit simpler. It's a bit smaller. It's easier to see what's going on. You have a function block. It's small and easy to understand. You have structured text. That's easy to understand. And if you have a big PLC with maybe 20 outputs, you can easily add value 6, 7, 8, 9, 10. Or whatever you want. And if you have an extension, connected to your PLC, you can easily use the function block to change the values. So if you don't want to use the internal outputs, you want to use the external outputs, you can change it to 102.0, 102.1. It's super easy to use. So it's basically the same program. It's an improved version of my previous program. Thank you for watching.